Hello everyone, welcome back to our channel. Now in this video we are going to start with a new data structure, that is graph. Okay, so let's understand what is graph and how do you implement graph on your own. Okay, a graph is nodes connected with each other, just like people are connected in a social media network. In tree also, if you remember, we had nodes, right? Where the structure was you had value, you had left child and right child, right? In a similar way, here also you have nodes. So those nodes, when they are connected to each other through edges, now that's called a graph. Now, two directly nodes connected are called neighbors or adjacent nodes. Now we have graph types, directed graph like Instagram. That means if you follow someone on Instagram, they need not to follow you back. Okay. Now that's an example of directed graph because you are following someone. Now it depends if on them if they follow you back or not. And then you have undirected graph like Facebook. In Facebook, if someone sends you a friend request or you send someone a friend request, basically once someone accept your request, right, you both are friends of each other. Okay, so that's called a undirected graph. When you add weight to the graphs, they are called weighted graphs. We'll be looking into that in some different algorithms. Now there are two ways to implement adjacency matrix and adjacency list. In adjacency matrix, what you have is a 2D array, and when you have two nodes connected to the edge, right, you fill that particular index value from 0 to 1. So you know these two nodes in a 2D array are connected to each other. Okay, and then you have adjacency list implementation. Adjacency list is often used to represent graph, and we are also going to implement using the same. For that, let's create a node structure, private class graph node. Now what this node can have, it can have a label. Now you need a constructor here. So now you have a constructor and you have a toString method for that particular node. Now let's move ahead. Now what you need a placeholder so that you can know how many nodes are there in your graph. For that we are going to take a map which is going to take the string and your graph node. Now we said that we are going to do this implementation using adjacency list. So let's create that as well. Now this map is going to have a node, that is our graph node, and this is going to store the list of nodes as values. Let's import our list. Now this is our adjacency list is equal to new hash map. Perfect. Now let's implement our add node method, which is public void add node. When you add node, you have to pass the label through which you want to create this node. Now to create, what you need, you have this nodes map. Let's add it to there, nodes dot put key will be your label, and as a value you need that particular graph node. So let's create that graph node separately. Graph node, new graph node. This is going to take the label through which you are creating this node. There is a possibility that you already have this node in the nodes map. So for that we can use a method put if absent. If it is not there, then only add this node there. Okay, so now you have added the nodes to your nodes collection. Now you can add it to your adjacency list as well. So you have that node in place, you create the adjacency list so that whenever you are creating edges, right, whenever you're adding edges, we can add it to that particular adjacency list. Okay, so adjacency list dot put. So this is going to take our node, which is our new node, and as a value you need the list of nodes. So this will be your array list. Basically there is your add node method implementation. You have created a new node, you have added the nodes to your collection if it is not already there, and for the adjacency list also you have added it for the node, and the list, so that you can add its edges respectively whenever you're going to add them. So let's implement that method for adding edges. So now edge can only be added between two nodes, right? So for that, what you need a string from and string to. So from this node you want to add an edge to this node. So before adding this edge, we want to check if these nodes exist in our graph or not. For that, what you can do, you can call nodes dot get from. So if this returns not null, right, then you know that these node exist in your graph. Option enter, introduce local variable. Now this will be your from node. Now let's add one more line. This will be your to node. From node is equal to null or to node is equal to null. You can throw an exception, illegal state exception, that's it. Now when both of these exist, right, then what you can do, you can go to your adjacency list and then get the from node. You're calling this adjacency list dot get from node, right? You will come to the source node and then you can call dot add to add the edge there. Now here you can add the to node. That's it. You are getting the source node and adding the edge from the to node. That's it. So there is your implementation of adding node and adding edge. Now in an undirected graph, this is how you add node and this is how you add edge. Let's have our main method. For now I'm adding only two edges, which is from A to B and A to C. So let's print our graph, directed graph dot print, and let's see which node is connected to which. Okay, so what is our output? A is connected to B comma C. So basically it is telling your A node is connected to B and A is connected to C, and that is what we have in our graph. That means this implementation that we have done is working perfectly fine. Now let's have a recap. Okay, so we understood what graph is. Now tree with cycles can also be called graphs. We know there are two types of graphs, directed and undirected. Okay, now there are two ways we can implement the graph: adjacency matrix and adjacency list. And then we came to the implementation. We created a graph node which can have a label. Then we created two collections. First is the nodes, which is going to have a count of how many nodes are there in your map, in your graph. And second is the adjacency list, which is our implementation, which is going to have your graph node, and as values it is going to have list of graph node. So you know this node is connected to these many nodes. Okay, so that's how you have this adjacency list implemented. Now you implemented your add node method, where you have created the new node and added only if it does not exist in the nodes collection. And then you have added the same thing to the adjacency list to create the placeholder for that new node and the array list where you are actually going to add whenever you add edges to it. Then you created the add edge implementation. First you verified both of the nodes through which you want to add an edge are there or not. If they are not there, you are throwing the exception. If they are there, you are getting the source node and then you're adding the edge to the destination node. This is just for example, we have implemented the print method. We got all the sources and as a target we got all the list of nodes and we have printed them, and that's how we got this output. So that was your introduction of what graph is, how many types of graphs are, and an implementation of how you can implement graph on your own using the adjacency list. And we have implemented add node and add edge method. Now we need to learn more things about how to remove, and there are a lot of algorithms involved in graph. Those we are going to learn next. That's all as part of this video. See you in the next one.